says the starting, you need an interface in order to manage that. If I go back to the example of the game, if I want to have a method in my program, practically, which will allow me to create instances when I need them, within that method, therefore, I'll need to have this hard-coded for each class. Is that right? So therefore, I'll need x1 equal a new, and there is an if statement around them. Is that right? So therefore, I'll need to write all of these different classes and all the instances, and there is an if statement between them, and that will return to you that type. But that means that is, again, it's hard-coded, these expectations. Okay. What I want, I don't want to hard-code them as well. I want to avoid the developer to go and write, I've got x1 to x50. These are the classes' name. I don't want the developers, my developers, to end up doing x1 temp equal a new x1. Else f, x2 equal x2 temp equal a new. Okay. How do we avoid that? We avoid that by one solution. If we think this is a set of classes I'm gonna use or not use in the future, and those are homogeneous classes, they are more or less related to each other, I'm going to group them, because I can't go and set an instance to a variable unless I have that variable already in place. Otherwise, I'll need to tweak the code. Or in real time, I can't do that. So I say those 50 classes, which I might need some of their instances on the way, and I don't want to explicitly as well creating these instances under the if statement, I'm gonna group them all under the umbrella of one superclass. Okay, I assume you've taken that before. That superclass is either an interface at the top, and they all implement that interface, all of them, the 50, they implement that interface. Or, if I have the opportunity to do the extend, I will make it an abstract class at the top. And I assume you know the difference between interface and class. Interface could have the method signatures only, and the implementation is within the classes implement that interface. Agree? Just to remind you, what is an interface? An interface, I write public x interface, curly bracket, and the definitions of the methods. No implementations of the methods. And I can't put variables inside. Abstract class, and a bit extra, but it's still public class. It's a class, it's not an interface, okay? I can put some variables inside, but still I put the method signatures in the methods, okay? Those there to stand at the top of an implementation, therefore they are there to be inherited. Either for polymorphism cases, where others needs to call them, and that call is going to be distributed all over, like the observer design pattern, or for other reasons. How did this help me? Practically, that's a very unique idea, because this helped me. If I have an interface called x at the top, then mx is inheriting that interface. I could have one single instance, because I want later on to create instances, right? For the subset of the classes. I could just declare one variable there. But that variable for the interface or the abstract class. Then when it comes to allocating the instance, I allocate an instance of its subclasses. Does that make sense? That is one unique idea. Okay, let's just clarify it again in a simpler way. If I'm going to use an instance of all of these sub 50, and I don't want to create all the instances from the start, I could have a great idea. Escape route is to only have the abstract class variable at the top, And I can later on, if I needed any of the subclasses instances, I can say x equal new imp_x, which is a subclass of the x. Does that make sense? And when I call any method, because obviously the interface has already got all the units, all the method declarations, they could pass it through to the subclasses to be called and to be executed. Does that make sense? So what I've just solved, I don't need anymore to create instances of all the 50 subclasses. And I don't need to declare their variables too. That's another big thing. Does that make sense? And I don't need to declare their variables too as well. I don't need to say x, temp_x, and semicolon. Where if I don't have the interface, I will need to do that as well. Because I will need later on, at later stage, to put an instance inside that variable. So I'll need to be declaring it, even though I am delaying its creation. Does that make sense? Okay. Therefore, we define an interface at the top. And then let the subclasses decide which object to instantiate and allocate to that instance. So the subclasses later on can decide. And then a factory method lets a class defer the instantiation to the subclasses. So then I create the method which will be able to say, okay, you want this instance? Yes, I'll give you this instance. It will go an if statement based on certain input. It will send you back an instance for that subclass. When do we use it? As I said, that example of a game. When a class can't anticipate the class of object it must create. Sometimes, in some cases, we don't know which subclasses we need. We don't know what instance we need until we get the input. I'll give you an example in a minute of an image reader. There is lots of types of images. Each image structure is different from the other. GIF has got a certain structure, JPEG has got a different structure, etc. Therefore, I don't know which class is going to process that until I get the file. When I get the file, then I decide. I'll go back to the swing example because it's good here. When I know the operating system, I'll create the swing related. That is what the VMware, the virtual machine of the Java is telling me. When I know which operating system I'm sitting on, and somebody double-click on that application needs a button, okay, I'll go and create a button for Windows. I know now. Otherwise, I don't. And sometimes, the explicit example, a class wants its subclasses to specify the objects it creates. Okay, that is the structure in a much more explicit way. I go here and I create a product, for example. That is an abstract class or an interface. These product X and product Y, these are subclasses. These which I want the instance of later on. But I don't know if I want X1 or X2 at the start. I might need them both. I might need one of them. If these are 50 products, classes, I might only use 5. So why to break my memory and load them all from the start? That's a good example. Then I've got a factory here, which is got an instance of product. Okay? And then where that method to create a product will do, can interact with these and set an instance of these to that instance declared here. So I'm declaring only one variable here of type product. Product X semicolon, and that's it at the start of the program. Then when I need sub a product, I'll say X equal new product X, and that's fine. Because later on when I call the methods, if I call the methods and that, these will be passed here to be executed. Like what we've done with the observer. And then my application will then utilize that factory in order to get the instance when needed. If I need product X, I get product X in instance at later stage. If I've got 50 classes, I got only one instance here, one variable declared. And I can associate with that instance one instance out of the 50 here. Therefore, it's a great idea. And that is called the factory design pattern. Okay. I'll take an example. This slide is all about refactoring, just introducing the concept of refactoring, because we're going to go through what we call refactoring an image reader program. Refactoring in simple detail, it's about improving the code after achieving the purpose, let's call it. I mean, you first tend to make sure that your program works. Okay, it works, but it is just like me in my PhD program, doing lots of things and it's all a total mess. We go through refactoring in order to make it look better, more efficient, reusable, etc. So we improve the status of the code. There is lots of steps we can go through. I'll take you through a simple example. And there is lots of refactoring, tactical movements and strategical movements, etc. Again, I tend to bring worst case scenario, then we move on. I presented earlier on, I talked about the image reader, which I've got a file which decode an image and then present it to you as a viewer of the image. The quick and dirty solution to that is one class called image reader,